Hi, today we're looking at 12.4 measures of dispersion. So the first thing we're going to find are the mean, median, and mid-range of these three sets of data. So remember, X bar is mean. So take a moment, find the mean, median, and mid-range. Okay, note they're all 45, even though they're definitely different sets of numbers. So two commonly used measures of dispersion are range and standard deviation. So these are going to allow us to kind of tease apart these different sets of numbers. Gives us more description of this number set that we're looking at. So the range of a variable is the largest data value minus the smallest data value. Range is high value minus low value, or just high minus low. So let's find the range of these data sets. For set A, it's 70 minus 20 equals 50. For set B, and for set C, so note that this is showing that these numbers are closer together in this data set. And if we look back up here, that looks to be true for set C. Okay, deviations from the mean. X is the raw score. X bar is the sample mean. The deviation from the mean is X minus X bar. So this is raw minus mean. Now let's take a look at this visual representation of data set A. Okay, so if this is our mean, 20 is below the mean, 70 is above the mean, and so on. So it shows that distance from the mean. Okay, we're going to skip this problem and move on to the next page. So we're going to consider this set of data. So A is going to be each one of these values. Then we need to find the mean. So the mean of this set of data is going to be 45. Okay, we already have figured that out for set A. So now we're going to take 20 minus 45, 30 minus 45, 40 minus 45, and so on. Okay, so I get negative 25, negative 15, negative 5, 5, 15, and 25. All right. So sample variance, this is a measure of dispersion, is S squared, or sometimes you'll see it like this, with a cursive S. It's the sum of deviations squared over the number minus 1. So that's what this is saying, sum of the deviations squared divided by n minus 1. So if we look down here, we have our deviations. Now we're going to square all our deviations. So take all these and square them. Okay, so we have our deviations squared up here. So now a sample standard deviation. Standard deviation is S, and it is the square root of the sample variance. So square root of S squared, or square root of the sum of X minus X bar squared over n minus 1. So we go ahead and we can figure out the sample standard deviation by performing these things here. Okay, so I'm going to add all these up. Okay. And then I'm going to divide by n minus 1. So give me just a second. Okay, so the sum is 1,750. We have to divide it by n minus 1, and n is the number of numbers. So we have 1, 2, 3, 4, 5, 6. So this would be 6 minus 1, or 5. So this is just working out the inside part here. Okay, so let's find that out. So 350. So then I'm taking the square root of 350. So this is 18.7 about. Okay, so the sample standard deviation is 18.7. So we want to fill in the chart. Sorry, it printed kind of funny. So this is the mean, median, mid-range, range, and standard deviation. Okay, so we knew all of these were 45. The range we figured out already. And the standard deviation we figured out for the first one. Now we have to figure it out for the next two data sets. So we're going to repeat the steps that we did for B and C. So let me start off B here. So I'm going to put each one of these values down as my X. So 20 minus 45, and so on. So I square each of them. Then I add them all together. Then I divide it by n minus 1. So n is 2, 3, 4, 5, 6. So divide it by 5. And then take the square root. So 15.94. Okay, let me give this next one a try. Okay, so filling out those standard deviations. Yeah, that should be better. We got the deviations, we squared them, added them up, divided by 5, took the square root, and should get 3.74. So what do you notice? The thing that I noticed here are that with the data set where the numbers are more spread out, I get a larger standard deviation. When I have a data set where the numbers are closer together, I get a smaller standard deviation. Okay, back to the Broncos. So here's the Broncos salaries again. You have them to look at. So then we're going to recall these measures of central tendency. Okay. Now we have a range and the standard deviation as well. Okay, so for part A, we could say half the Broncos make more than 570,000 and half make less because that's our median. Most Broncos make, so mode, for most, it was 49,500. Okay. And then we could say their salaries are very spread out because that standard deviation is really large. Okay, so take a moment, read over the question, and check out that table. So in Finch Valley, let's look at their mean, median, mid-range, range, standard deviation. So it looks like there's some homes that are really expensive, though half are less than 300,000. The prices are really spread out because there's a huge standard deviation. Okay, if we look at Rabbit Gables, we can see that half the houses are still under 300,000 and half above. These house prices are closer together. Their range is smaller and the standard deviation is smaller in comparison to Finch Valley. Deer Park. So all the houses cost exactly $300,000 in Deer Park. There's no difference at all. So which neighborhood would you choose and why? That's up to you. You can just answer that. What do you think? Okay, I hope this helps.